All right, welcome back. Next section, 6.1, slope fields. I know you guys love this from last year because it was ridiculously easy. And it's going to be pretty easy as well. We'll do two different types of examples and we'll get into the rest of it. So, not all differential equations can be solved using separation of variables. These are called inseparable differentiable equations. And so, if you ever take a class, it's called ordinary differential equations. I didn't have to because I went the theoretical math route. If you're going to be an engineer, then you're probably going to have to take this. It's like, I think for you guys, it's like Calc 3. We had multivariate calculus, which is Calc 3, but that's different than Diffie-Q. Anyway, you can graphically represent the solution to the differential equation using a slope field. Basically, they're just short line segments to represent tangent lines at specific points on a plane. Okay, so there's the solutions to the differential equation. There are the slopes at that of the tangent line. And then basically we can put all of those kind of slopes together and kind of mimic what the solution curve is going to look like. All right, so for instance, if I have this separation, so I want to use separation of variables to find the solution, then I want to graph the slope field for the differential equation at the points indicated on the graph. Okay, so what I'm going to do first is I am going to kind of draw the slope. So if this is 1 and I plug it into the actual derivative, right? So dy dx is equal to x, or y prime is equal to x. I'm going to plug in the values of x comma y, but really because it's just an x, I don't need the y values, right? So if I plug in x to be 1, that means the slope is going to be 1. And then anywhere over here, the slope's going to be 1. Anywhere over here, the slope's going to be 2, right? And so on. Actually, this is going to be 1 as well, and so on. You guys just drawing lines, right? Down here, it's 0, right? So anything on the y-axis is going to be 0, because x is 0. And then this is going to be -1, right? So -1. You gotta do as best as you can. I know it's kind of hard to say what if it's 4, what if it's 8, what if it's 16. Like, you gotta do as best as you can. It's not going to be 100% accurate, but it's going to be somewhat close. Like if I'm drawing this and I want it to be -2, which, okay, that looks like a -2, but if that answer should be like +7, like obviously wrong, or if it should be maybe a half, that's probably going to be wrong too. So you got to be somewhat close. You can't just be way off and they'll give you credit for it. So what I want to do is use separation of variables. Okay, I want to take the equation up here, right, this slope, and I want to separate the variables just like I did in the last section. So move x's to one side, y's to the other. So I get dy is equal to x dx. Now I want to integrate them. Okay, this is just y, right? Because that's just 1, integrate that, it's y, is equal to, this is x squared over 2 plus some value of c. So this is your solution, okay, that's your solution to basically this Diffie-Q, okay, this differential equation. And so what it means by that is, this is a parabola, right, x squared over 2 is a parabola, plus some c. So the value of c, depending upon what c is, so for instance, if c is 2, okay, if c is 2, that means the graph is going to get shifted up at 2, right? And then the graph is 1/2 times x squared. So my slope is basically a half. So I'm going to go up 1 over 2, so it's like over here, and it's going to be a very, very flat kind of parabola, right? So this is when c is equal to 2. What if c is equal to 1? Then my graph is going to go here, right? And then it's going to go and kind of go in this way. So it's going to curve down and go that way, right? So that's c is equal to 1. What if c is equal to 0? So then it's going to go here, and you can see that the 1/2 is going to do that. So that's c is equal to 0, and so on. That's what I wanted to kind of talk about with c is equal to -1. It's going to be the same kind of thing. So we can kind of see what's going on there between those solution curves. Based on, it changes based on what c is, but for the most part, that's okay. Now, what it might ask you is, it might ask it to go through a certain point. Okay, so if you're given a point, like, what's the solution curve at 1, 0, then you're going to have to draw a solution curve through 1, 0. And that's what we're going to do down here. All right, so this one's pretty easy. We're not using separation of variables to mimic the solution curve, we actually are already given what we already need. So we're given the derivative, 2x plus y is equal to y prime, or, right, dy dx. And we want to find the solution curve through the point 1, 1. So I'm going to plug 1, 1 into here and find out what's going on there. So if I plug 1 in, I get 3. So y prime of 1 comma 1, I get 3. And so at 1, 1, I'm going to get 3. So we're going to go, ooh, that's pretty vertical. I don't want to go that vertical. We'll go like that. Okay, and I want to plug in all the other points. So this is 1 comma 0. So y prime at 1 comma 0 is just 2, right? So that's going to be not quite as steep, and that maybe is very similar, but 2 and 3 is very hard to tell. And it's fun to other points. Okay, what about 0 comma 1? Y prime at 0 comma 1 is going to be right here. So that's just 1. Right, so that's going to go like that. Y prime at negative 1, 1, that's equal to negative 1. So negative 1, 1, that's equal to negative 1. So that's going to go like this, and so on. And you would do the rest of them. Okay, you would have to fill in this whole slope field based on every single point that is given to you, and that's, you've done that on the AP test, like it's nothing new. Okay, so I'm going to fill that in real quick, and you're going to basically have to do this for all your points, right? So all the way through all of the other 5, 6, 7, 8, 9, 10, 11, 16 points. All right, I'm just going to do it real quick. So I get 0 there. This looks like to be negative. This is a little bit higher, a little bit higher. This is like that. This is like that, and so on. Basically, you're going to do this. I'm just going to do it real fast here. Okay, and this is flat. This is positive, positive. This is bigger positive, biggest. And there we go. So now the solution curve through 1 comma 1. Okay, so 1 comma 1 is right here. So what's actually happening? Okay, our graph looks like it's coming down to this right here. Okay, to that horizontal asymptote, right? And it looks like it's going right back up. So something is going on with the graph. All right, and it does have to cross 1 comma 1. I kind of didn't make a good graph there, but let me see if I can go backwards and do that. So here we go, and then kind of like that. Okay, so it's a parabola. It looks to be a parabola based on the curves of the graph. Okay, that's it for this video. Hopefully it's easy just like last year, and we'll get to the next one. Deuces.